Imagine you are handed a massive new software project. You have a budget of 50 million rupees, a timeline of 1 year, and a team of 25 eager developers. On paper, everything looks perfect. 6 months pass and the project is only 30% complete. 1 year later, your budget balloons to over 12 million. 2 years later, the software is still crawling with bugs, and finally, the entire project is canceled. The developers involved didn't lack programming skills. They knew exactly how to write code. Their true blind spot was managing a software project at a massive scale. In the early days of computing, writing software meant dealing with small, isolated programs. You could manage hundreds of lines of logic without much overhead. As the industry moved toward building entire operating systems and global networks, the code expanded to millions of lines. Old methods broke under this weight. This systemic failure occurred so frequently during the 1960s and 70s that it earned a permanent name, the software crisis. Projects collapsed repeatedly because the complexity of the systems vastly outgrew the processes used to build them. This diagram maps out exactly why these systems collapsed, starting with sheer size and system complexity. Modern software forces multiple systems, login, search, orders, and payments to execute simultaneously. Compounding this is poor planning. Developers would often start coding immediately, only for the client to change the requirements midway through the build. Forcing a live chat or AI feature into an unplanned architecture guarantees structural chaos. Then we add human error. The client asks for a shopping app, but the developer builds inventory software due to poor communication. Without strict documentation, new developers joining the team are completely blind to how thousands of existing files interact. Finally, project managers routinely underestimated both time and risks, while development teams delayed testing until the very end. Finding thousands of bugs at the last minute is vastly more expensive than catching them early. Let's test this logic. If a client demands a massive AI recommendation engine exactly halfway through a build, which of these causes does that trigger? And what happens next? That triggers changing requirements. The immediate fallout is a massive mandatory rewrite, driving up both delays and costs. Looking at the complete chart, we see how all 8 friction points funnel directly into 6 project-killing effects. Budgets explode, delivery dates are missed, the code becomes impossible to maintain, quality drops, customers lose trust, and the project ultimately fails. To solve these ongoing failures, the industry adopted a rigorous step-by-step workflow. We call this discipline software engineering. Think of construction. Building a bridge randomly guarantees a collapse. Civil engineering requires designing blueprints to ensure stability first. Software engineering applies this exact methodology to code through a life cycle: requirement analysis, planning, design, coding, testing, deployment, and maintenance. This table summarizes the shift. By forcing strict order and deliberate planning onto a previously chaotic process, developers finally gained the ability to deliver reliable, complex software on time.